Hello, BSc first year chemistry. Today we are discussing about hybridization. Hybridization. The topic name is already we are discussing. So once again I repeat hybridization. What is hybridization? Most important one. Hybridization. What is hybridization? Intermixing of intermixing of intermixing of two or more intermixing of two or more orbitals are combined to give a new equivalent orbitals are called hybrid orbitals. This process is known as hybridization. Simple. What is hybridization? Intermixing of two or more orbitals are combined to give a new equivalent hybrid orbitals. This process is known as hybridization. Intermixing of two or more orbitals. Are combined. So intermixing of two or more orbitals. Now, number of orbitals. There are four types of orbitals. Number one, SPDF. Orbitals are SPDF. Intermixing of two or more orbitals are combined to give a new equivalent hybrid orbitals. This process is known as hybridization. So, what are orbitals? SPDF. These four different orbitals are combined. Orbitals are SPDF. Then types of hybridization. Hybridization types. Number one, sp hybridization. Number two, sp2. Number three, sp3. Number four, sp3d. Number five, sp3d2. Last one, sp3d3 hybridization. Then sp hybrid. What is sp hybridization? Simple. Intermixing of, once again I repeat, what is hybridization? Intermixing of two or more orbitals are combined. Here, what is this sp hybridization? Intermixing of one s orbital and one p orbital are combined. Here, intermixing of one s orbitals and two p orbitals. And sp3, intermixing of one s orbital, three p orbitals. And sp3d, intermixing of s orbital, three p orbitals and one p orbital. Last one, sp3d2, intermixing of one s orbital, three p orbitals, two p orbitals. Finally, sp3d3, intermixing of one s orbital, 3 p orbitals and 3 p orbitals. Once again I repeat, types of hybridizations. There are 6 types of hybridization: sp, sp2, sp3, sp3d, sp3d2, sp3d3. Now take examples. For sp hybridization example, BeCl2, BeCl2 beryllium chloride. For sp hybridization example, BCl. For sp3 hybridization example, H2, NH3 and CH4. For sp3d hybridization example, PCl5. For sp3d2 hybridization example, SF6. For sp3d3 example, IF7. These different types of examples we are discussing in this. Once again I repeat, what is hybridization? Intermixing of two or more orbitals are combined to give a new equivalent hybrid orbitals. This process is known as hybridization. The number of orbitals are 4. Orbitals are s, p, d, f. Types of hybridization: sp, sp2, sp3, sp3d, sp3d2 and sp3d3. Now we are discussing sp hybridization. sp hybridization means intermixing of one s orbital and one p orbital are intermixed to give a new equivalent hybrid orbital. That is sp hybridization. We take an example: beryllium chloride. Beryllium chloride. Beryllium has 2 chlorines. In between the chlorines, one beryllium atom in between the 2 chlorines. So the center atom is beryllium. Center atom is beryllium. Beryllium atomic number: hydrogen, helium, lithium and beryllium. Beryllium atomic number 4, 1s2, 2s2, 2p, 0. Only 4 electrons. 1, 2, 1, 2, 2p, 0. Empty orbital. But every beryllium atom reacts with 2 chlorines. So we want 2 unpair of electron in the beryllium atom. But here all are pair electrons. So now these electrons jumps from 2s orbitals to 2p orbitals. Now at the excited state of beryllium, number of unpair of electrons are 2. Now intermixing of these 2 orbitals. These 2 orbitals are intermixed. Now we are with 2 chlorines. This one is beryllium. Beryllium reacts with 2 chlorines. In between the 2 chlorines, the bond angle is 190 degrees. So bond angle 190 degrees. And hybridization is already we discussed. sp hybridization. Shape of the molecule. Linear shape. Shape of the molecule, linear shape. Once again I repeat, what is sp hybridization? Intermixing of one s orbital and one p orbital are intermixed to give a new equivalent hybrid orbitals called sp hybrid orbitals. This process is known as sp hybridization. The example is beryllium chloride. Every beryllium atom reacts with 2 chlorines, so the center atom is beryllium. Beryllium atomic number 4. Electronic configuration is 1s2, 2s2, 2p0. Here all are paired electrons, but beryllium reacts with two chlorines. Beryllium reacts with two chlorines, so two unpair of electrons. We want two unpair of electrons. So now this electron jumps from s orbitals to p orbital in the ground state, go to excited state. Only two unpair of electrons. These two unpair of electrons are intermixed to give a new equivalent hybrid orbitals. These orbitals are called sp hybrid orbitals. Now reacts with two chlorines. At the now reacts with two chlorines. So beryllium chloride. Beryllium in between the chlorines. So the bond angle between the two chlorines at any time in 180 degrees hybridization is sp hybridization, and the shape of the molecule is linear shape. This is the sp hybridization. Then we go to sp2 hybridization. sp2 hybridization. sp2 hybridization. What is sp2 hybridization? Intermixing of one s orbital and two p orbitals. Intermixing of one s orbitals and two p orbitals are intermixed to give combined to give a new equivalent hybrid orbitals. They are called as sp2 hybrid orbitals. This process is known as sp2 hybridization. We take an example BCl3 boron trichloride. Boron trichloride means the boron atom reacts with three chlorines. So the center atom is boron atomic number 5. Every boron atom reacts with three chlorines. So in boron atom, 3 unpair of electrons. You want 3 unpair of electrons. So we have the electron configuration of boron 1s2, 2s2 and 2p1. This is the ground state electronic configuration. 5 electrons, only 1 ampere of electrons. But we want 3 ampere of electrons. So this electrons moves from s orbitals to p orbital. Now this is the first excited state of boron. Now intermixing sp2 hybridization, intermixing of one s orbital, two p orbitals. Intermixing two p orbitals combined to give sp2 hybrid orbitals. These three ampere of electrons are react with three different chlorines. Gives BCl3 boron trichloride. In between the two chlorines, the bond angle is 120 degrees. Hybridization sp2 hybridization, and shape of the ion is trigonal planar. So again I repeat, sp2 hybridization, intermixing of one s orbital and two p orbitals are combined to give a new equivalent hybrid orbitals. These type of hybrid orbitals are known as sp2 hybrid orbitals. This process is known as sp2 hybridization. We take an example, boron trichloride. Boron trichloride means every boron atom reacts with three chlorines. So the center atom is boron. Boron electronic configuration 1s2, 2s2, 2p1. Every boron atom reacts with three chlorines. So we want 3 ampere of electrons in the boron, but only 1 ampere of electron in the ground state electron configuration of boron. So now this electron jumps from s orbitals to p orbital. At the excited state of boron, 3 ampere of electrons. So now intermixing of one s orbital and two p orbitals are combined to give a new equivalent hybrid orbitals. These hybrid orbitals are called sp2 hybrid orbitals. Now these unpair of electrons are reacting with three different chlorines to form BCl3 molecule. In between the every two chlorines. The bond angle is 120 degrees, hybridization is sp2, and shape of the molecule is trigonal planar. Next, sp3, sp3d, sp3d2, sp3d3 hybridizations I am discussing in next class. Thank you.